Hello everybody, this is Dr. Eldek, and today I will talk about the most important experiment because it weighs 25%, because you have to do a formal report for this one, and it's very important because if you do not submit a report, you will lose 25%. So in this case, you will not be able to get B, for example. So let us go through it. The objective of this experiment is to build and measure operation amplifier circuits in BSpice and analog discovery board. So this is the operation amplifier that we will use. It's called OP27G, and it is found in the analog parts kit. You can find it. And when you notice here, you notice that this has a notch like this notch. And from this notch, you can name the legs or number the legs. This is 1, 2, 3, 4, 5, 6, 7, 8, like what we have here. 1, 2, 3, 4 until 8. And if from inside, if you look at if this is the notch, then you know that 2 and 3 are the two inputs of the operation amplifier. And the number 6 is the output. So you know that these are the legs that you will use. Also, you know that this operation amplifier is powered by positive voltage and negative voltage. It must be working with positive and negative voltage. Usually, operation amplifier is working with, let us say, 15 volt, for example. But I selected this one because it can work with positive and negative 5, which is available in analog discovery board. So the green one, which is leg number 4, is connected to the negative volt, and the red one is connected to the positive volt. Okay. So this is almost all what you need to know about this chip for the operation amplifier. The first step here is to do inverting amplifier using analog discovery board and using BSpice. But let us just do it by calculation. We know the inverting amplifier, the output equal negative the input over the output equal the negative the output resistance divided by the input resistance times the source. So here it is. This is the relation. Then in this case, if Vn is sine 2000 by t, for example, then Vo or V out here equal what? Equal negative this resistance divided by this one time sine 2000 by t. Then here you will have a negative sine 2000 by t. Here you will have negative 1.5 sine 2000 by t. Here you will have negative 2.2 sine 2000 by t, and so on. So this is in calculation. In calculation, it look like this. Until the end, of course, this one will be negative 6.8 sine 2000 by t. But in reality, when you do it in using BSpice or using analog discovery board, when you build a real circuit, you will not have it like this. Why? Because, as I said, the operation amplifier is running by a DC voltage, which is the one that we use here is positive and negative 5 volt. Then the output cannot exceed this range, cannot be more than positive 5, cannot be less than negative 5. Then if it happens that the voltage is more than positive 5 or less than negative 5 volt, then in this case it will be clipped. It will be clipped, as we will see. So non-inverting amplifier, the difference between inverting and non-inverting is that we switch the position here. The source, instead of connecting the source here and the ground here, we switch. So the ground will be connected here and the source is connected here. Then the relation will change. Then V out equal 1 plus R2, which is output resistance, divided by the input resistance, which is R1, all time Vn, or the source voltage, which is sine 2000 by t. So let us, for example, do it using BSpice first. So if we open BSpice, let's open it. Okay, here it is. Then what we need to do is to add a device and this op amp. You can add an op amp like this. Device and op amp. Then you need how many? You need the two resistors. So you need resistor and another resistor. Okay. And you need a source. So you need a device and source, voltage source. Rotate it like this. And you need what else? You need ground device and then ground. Here, for example. What else we need? Let us see. Let's just finish this, and then after that we'll see what else is required. So, for example, this is the grounds connected here. This one is connected to this one. This one is connected to the source. This is connected to the ground. Okay. This is connected to. Okay. And this is connected to the output. Then now we have, this is the output voltage here, and the input voltage is here. Okay, but we still have something remaining here, that we must have connect a positive voltage and negative voltage. So we need to add two voltage sources here. You can add them as you like. So you have two voltage sources. One is positive, and you can add another one which is negative. We need to switch this one here. So this one is negative, this one is positive. So V2 is positive because it's positive here. This one is negative. Okay. So you need to connect, for example, this positive voltage to this one here. Okay, and the negative voltage you connect it to the other one. You can connect it directly here. There it is, like this. Okay, and the other one you can connect it through wire. So I need to connect it like this. You can make it like this. And now you need to connect this, and there it is. Now let's just make it like this. So you see here now, this is a positive voltage, this is a negative voltage, and this is the source. So now we are ready to find everything we need, anything we need. Okay, so let us now do the setup. The circuit is ready now. The setup. The resistance, let's keep it 1 kilo ohm right now. 1 kilo, 1 kilo. The voltage, what's the voltage? Well, the voltage is sine wave, then we have to select sinusoidal. Don't worry about this because you have to, this is for the DC. Then select transient property, and the peak is 1. The peak voltage is 1 because it is 1 sine 2000 t. And the frequency is 1000, then it is 1 kilo ohm. You can write 1 kilo ohm. Then accept. Now make sure that it is accepted. So it is 1 kilo ohm. Now we have the source. Okay, now we have the source. Then after that we need to go to simulation and set up simulation and select op.op, and we select transient Fourier analysis because we have AC. Then we select this one, we click this one here, and then we set up this numbers here. The period for 1 kilohertz is 1 milliseconds. And if you want to display, for example, let's say we want to display two periods, and we need to make it 2 milliseconds. If you want to display only one, that's fine. So let's say okay, and then we can run away, or you can just keep it like this now. And then after that, we need to run the simulation. Before we run the simulation, remember that we have to check this numbers here. So for example, the input here, we need to display the input, which is node number 1, number 6. Is node number 6. And we need to display the output, which is node number 5 here. Node number 5, so 6 and 5. Remember that these numbers, even if I try to do the same circuit right now again, maybe will be different, will be completely different. So there will not be 6 and 5, okay, when you do it. So now just record that this is 6 and 5 and then run the simulation. When you run the simulation, it will not show, of course, any voltage or anything because you do not plot a signal. Do not have a plot. Then, as I said before, in experiment number 8, while this one is on the top, when you say here, they say here there is no active plots. Okay, you have to go to edit and then edit plots. Okay, then you add the voltages that you want to display. We need to display 5, which is the input is 6, I believe. The input is 6, and 5, which is the output. And then you say OK. When you do that, you will see the input and output signal. The input and output signal. But it seems that there's something wrong here. Let's see. This is V5. V6 is fine here. This is the source. Okay, but there's something wrong in the output. Let us check what is wrong here. Yes, I forgot to do something here. Okay, what is this something? Good that I did that. What's this something? Think about it and see what is missing here. Why I do not have any output? The output is 0. You see, this is the output. V5 is always 0. You don't have any output, but you have input. So what's the problem? Think about it for a moment. The problem is that I did not add positive and negative voltage. You have the sources, but there's no value. So you have V2 and V3, but you don't have values. You have to make this one 5 volt, and this one you have to make it also 5 volt. Okay, that's it. But remember, this is positive 5, but it is connected to the negative, then it will be negative 5. So the value is positive 5, positive 5. Now let us run the simulation again and see what will happen. We will have inverting amplifier. This time, I'm sure we'll have inverting amplifier, as you see. So you see, where is V6? This is the input, and this is the output. You see, they are opposite to each other. V out is negative Vn, because you have 1K and 1K. Okay? So, which is right. Now, let us see what will happen if we change resistance to, for example, 4.7K. In this case, you expect the voltage to be 4.7K or negative 4.7K sine 2000T. So let's run the simulation and see what happened here. This one is supposed to be 4.7K. You see the difference? Okay. Let us run the simulation again, and now you can see it here. So this is 1, this is the input, V6 is the input, is 1, the amplitude is 1, it's very clear. What about the output? The output is here, which is V6, V5. Then if you want to know exactly what is the maximum here, you can try to find the pick the maximum. Will not be perfect, but it's okay. You can select this one, for example. This looks to me as the top, the peak. So what is the peak value? 4.694 volt, which is almost 4.7. Okay, so this is right. What will happen if we increase the resistance to 6.8K? Let us see. If you go to the circuit and change this one to 6.8K. Okay. It is supposed to be negative 6.8 sine 2000 by T. But what will happen, because 6.8 is more than 5, then in this case it will be clipped. It will be clipped, as we will see here. Run the simulation and see it is clipped. See, it is clipped at negative 5 and positive 5. Negative 5 and positive 5. And you can try more resistors. If you make it, for example, 100, so on, you will have even something that's very close to a square wave. So this one is 100K. Run the simulation, see how it looks like. It is very close to square wave. Okay, so this means that you can use the operation amplifier to generate a square wave using this because of this property. Okay, why? Because it is clipped at the negative voltage and positive voltage values, -5 and +5. It cannot exceed this value. Theoretically, if the voltage the resistance is 100K, then the output is supposed to be -100/1 will be -100 times the input. Okay, but here it will not work like this. Why? Because this is the source that you submit to the you run the operation amplifier using this source, -5 and +5. Exactly like when you, for example, if I give you $100 and you go to the mall, you cannot spend more than $100. You cannot spend 200. That's it. You can spend less, but you cannot spend more than 100. This is what you do also in the operation amplifier. You give it -5 and +5. They cannot spend more than this. It cannot give you more than this. It cannot give you outside this range from -5 to +5. Now assume, for example, that you want to change this one to non-inverting amplifier. It is not part of the circuit of the experiment, but it is just a simple work you can do. Let us make this 1 kilo again. Okay, as now what you need to do is just exchange the position here. So let us move this here. This one is a source. You connect it here, and then you connect it to the ground, and then you connect this point to this point. Okay, so now we just exchange the position of the source and the ground. Now we have non-inverting amplifier. Then the output will be 1 plus R2/R1 times input. Okay, so now according to this, if R2 and R1 are 1, both of them are 1, that will be 2. The output will be 2 times input. Then let us see. Now, if we run the simulation and see what will happen, we will have something funny. Let's see. Okay, where is the circuit? Where is the signal? I can't see the signal. What happened here? Where is the input and output signal? I see only one. So what's the problem? The problem is that when I did this change, the number of the node number is changed. See? Look at this. Now the source is connected to node number 3. And now you want to display 3 and the output, which is 5. Then you go to the output here, and then you edit it. You go to edit plot. It is edit plot. You have V5, then you need to add V3. So V3 is the input, V5 is the output, and now when you hit OK, you will see both of them, which is great. Why? Because as you see here, you have this is the input, which is the orange one. This is the input, V3. Okay, and the output is double of it, 2 times the input, and they are in phase. It's positive. This is non-inverting amplifier. In the inverting amplifier, the voltage, the input and output are opposite to each other, so positive and negative. Like I can't make it. One is positive, one is negative. Okay, here the both have the same direction, positive or negative. Okay, now assume that I did the same like in the previous one. I changed this one to, for example, 6.8 or 4.7. Remember 4.7, it was okay in the previous one. 4.7 was okay, but here it will not be okay. Why? Because it will be 4.7 divided by 1, that's 4.7, plus 1 will be 5.7. Then the output will be 5.7 times the input. So in this case, it will exceed 5. So now if you run the simulation, you will see that it is clipped. Okay, it's clipped at 5. Clipped at 5. Okay, and if you do it for 6.8, it will be even more because the amplitude will be higher, will be 7.8. Okay, and so on. So this is the first part of this experiment, is to do BSpice.